Okay, this is 1.6 chemical formula and chemical equations. Formula with an E because we're British anyway. Oops. Sorry. See, ionic formula. So, ionic formula is a metal and nonmetal, a cation and an anion. It doesn't have to be a nonmetal. It could be a polyatomic ion, like a number 2. And it's based on where they are on the periodic table. Polyatomic just means it has more than one atom. You do drop and swap, so you swap the charges. You drop the charges and you swap the values. And charges must be balanced. That's why you have the drop and swap. So here's your periodic table, handy dandy. Here's your +1 charge, alkali metals. Alkali earth metals are generally +2. You have oxidation numbers that vary depending on the transition metals, except a few ones you have to remember. Boron group is generally +3. The carbon group ±4 because it could be a non-metal like carbon would be -. -3 for nitrogen group. When you get down to antimony and bismuth, there'll be different oxidation numbers, but generally you're looking at nitrogen and phosphorus anyway. Oxygen group is -2, the halogens -1, and noble gases are 0. That's why they're unreactive. Here's some common polyatomic ions. You will get a handy dandy handout on this on Monday. And ammonium's really the only general plus cation charge. Everything else is negative. You have carbonate, hydrogen carbonate, which is also called bicarbonate. Nitrate and phosphate and sulfates all have highest number of oxygen in their general group, like nitrite and sulfite. So writing an ionic compound, you will basically just need to know the charge and the symbol. Magnesium chloride is MgCl2 because Mg is +2, Cl is -1, so they drop the charges, so you don't care about plus and minus, and then you swap the numbers, so the 2 goes to chlorine and the 1 goes to magnesium. Sodium nitrate, same thing. They're both +1 and -1, so they cancel out. Iron 3 bromide, the 3 Roman numeral means it has a +3 charge. So when you do the drop and swap, it's FeBr3. Silver oxide. Silver, you're like, oh man, it's a transition metal. I'm like, yes, it is, but it only has a +1 charge. So you will not write the Roman numeral for silver. So for silver oxide, the 2 from oxygen goes to silver, and the 1 from silver goes to oxygen. So the 3 major transition metals that do not have a various oxidation number is silver, cadmium, and zinc. Cadmium and zinc are +2, and we just talked about silver being +1. Alright, writing the name. Writing the name is easier, unless you have a transition metal, it can be a little difficult. For here, zinc is only going to be +2, so we don't have to write the Roman numeral, so it's zinc chloride. Lithium is Li, CO3 is carbonate, so it's lithium carbonate. C is tricky because you have Mn and oxygen's already, is -2. This actually comes out to be manganese 4 oxide. You can try it out, do the oxidation numbers plus and minus, and then do your drop and swap, and it will come out to be MnO2. Calcium sulfate is CaSO4. Okay, here's some other compounds with oxygen, with 8s. So the first 2 you already talked about with the common polyatomics, sulfate ion and phosphate ion. And here we have sodium sulfate, and then CO3 is carbonate, it's calcium carbonate, and OH is hydroxide, so it's sodium hydroxide. Naming continued, more practice, making sure you know the names, so you should be able to look at it and name it, and that's sodium phosphate. NH4 is your polyatomic that's only a positive charge, so it's ammonium sulfate. AlCl3, you have aluminum chloride, And then number 4, you have calcium, and NO3 is nitrate, so it's calcium nitrate. Okay, covalent formula. So covalent depends on the number of electrons needed to complete the outer shell. So from the carbon group, which is the basic first negative charge ion, going to the halogens, it goes down in number of bonds, so it's 4, 3, 2, and 1. And that's the reason why they're on the periodic table, because it's based on their bonding as well. So in covalent compounds, you use a prefix: mono, di, tri, tetra, penta, hexa, hepta, octa, non, deca, so forth. No mono if it's the first atom. So mono carbon dioxide is not true. You would just say carbon dioxide, even though there's only one carbon. And the periodic table, there's no need to look at it unless you need to spell something. There's no drop and swap, so the ions do not matter, or where they are. Okay, here's some practice ones. You have carbon tetrachloride, so carbon, since it's just by itself, is just 1, and then tetra means 4, so it's CaCl4. Dihydrogen monoxide, the most dangerous chemical out there, H2O. Sulfur hexafluoride, and then you gotta talk really low because sulfur hexafluoride changes their voice deeper. And fluorine dioxide, so 2 oxygens, 1 fluorine, FO2. The naming is the same way. You just gotta remember to put the mono if it's at the end, the second element. Here we have sulfur and bromine. There's 5 bromines, so it's sulfur pentabromide. NO3, there's nitrogen, and tri is 3, so it's trioxide, nitrogen trioxide. H2S, dihydrogen monosulfide. Mono because it's the second element. And then you got xenon with 8 fluorines, so it's xenon octafluoride. Balancing chemical equations. This is pretty much just a review. Remember that you gotta make sure all the atoms are equal on both sides to be balanced. Like here, you have 4 hydrogens. That's reactant side. That's your product side, and there's your yield sign. You gotta make sure you know what those are. And then the numbers in front are coefficients. Here we have liquid ethanol. C2H5OH burns with oxygen gas to produce water vapor and carbon dioxide. Okay. So we gotta do an atom inventory. How many carbons? There's 2 carbons, 6 hydrogens, and 3 oxygens. You gotta remember in ethanol there's 1 oxygen. And then on the right side there are 1 carbon, 2 hydrogens, and 3 oxygens. None of them are balanced except oxygen, which you always want to leave to the end when you're dealing with combustion reactions like this. So carbon's easy to balance. You put a 2 in front of CO2, and that changes carbon to 2, but it also changes oxygen to not 6, 5. 4 from the CO2, and then 1 from the water. Now you gotta balance the hydrogen, so you gotta put a 3 in front of H2O to make it turn into 6. 3 times 2 is 6. And that changes oxygen once again to 3 from the water and 4, so you get a total of 7. Okay, so now we have to change oxygen. Remember, in ethanol there's already 1 oxygen, so we only need 6 from the O2, so you put a 3 there, because 3 times 2 is 6. 6 plus 1 is 7, and you get balanced. Ta-da! Check. Alright, here are your homework questions. There are 3 of them. If you need to look up the formulas for those, you should know them. But iron, just Fe, reacts with hydrochloric acid, which is HCl, to form iron 2 chloride and hydrogen gas. And then in letter B, aluminum hydroxide, hydroxide again is OH, decomposes on heating to form solid aluminum oxide and liquid water. And then liquid octane burns in oxygen. Remember, oxygen is diatomic, so it's O2 to form carbon dioxide and water vapor, typical combustion reaction. Okay, next up is writing the net ionic equations. So net ionic basically just means you only care about the ions that actually change in the reaction. So when you put something in solution, you have ions. Some ions don't react and some ions do. The ones you care about are the ones that do. The ones that don't are called the spectator ions. Just like spectators in a sporting event, they just there to cheer them on. They're like, "Yay, go ions!" And then you have the ionic equation, just the ions that are involved. So here is a very typical question example. You have zinc and copper sulfate. Turns the zinc into a cruddy black solid, which is actually when you purify it, turns into copper. And then the solution becomes less blue because copper sulfate is a very vibrant blue color. It turns paler because the blue is not in solution anymore, it's in the solid form of copper. So what we care about here is, one, we gotta make sure we balance it, which it is. Two, we break apart the solutions into the ions. So copper sulfate is broken apart into their ions, and then zinc sulfate's broken apart into their ions. Okay. Part 3, cross out the spectator ions, the ones that do not change state. So if you notice, zinc on the reactant side is solid, zinc on the product side is aqueous. So that means there is a change, so you can't cross out zinc. Copper is aqueous on the reactant side and goes to solid, so that changes. Excuse me. I had a sneeze. Sulfate, SO42-, does not change. It goes from aqueous to stays aqueous. So we cross out sulfate. Then you just write the reaction without the spectator, and there is your net ionic equation. Double check atoms and charges. You have +2 on the left side, +2 on the right side, 1 zinc, 1 zinc, 1 copper, 1 copper. Here's another example we'll do. We have magnesium. So the first step is to balance, which it is, 2 HCl's. And you should be able to get the final answer of the hydrogen ions and magnesium only involved in the net ionic equation, because chlorine is aqueous on both sides. So make sure you write out the example and see if you have any questions. Check out number 14. So you want to make sure you do this practice one. You break apart all the aqueous. So H2SO4 gets broken apart, NaOH gets broken apart, and so does Na2SO4 gets broken apart. And you should come out to be the answer of making water. 2H plus 2OH minus, and then yields 2 waters. That can be reduced to H plus OH and just H2O, because everything is just 2 in coefficients. That is a neutralization reaction. Alright, precipitation. Precipitate reactions make a precipitate. PPT, you know me. So in this case, you care about just what is being formed in the precipitate, which is the solid. So here's an example. We have zinc chloride and NaOH, and you make zinc hydroxide solid and NaCl aqueous. So what we care about is the solid part, which is the zinc hydroxide. So that means what makes up zinc hydroxide is the zinc ion and the hydroxide ion. And just make sure it's balanced. You bring down the 2 from the NaOH, and you're all good to go. So the AQs cancel out that are not important, the spectator ones. We just care about the ones that are making the solid. Alright, here's another workout example on page 14. We look for the solid, which is FeOH2. and that means you need the iron, which has a +2 charge, and the OH, which has a -1 charge. And you bring down the 2 from the NaOH, and you're good to go. So you should be able to write this out and get the answer. Again, any questions you can always ask. One of my favorites, making 2 liquids turn into yellow. Yellow per solid, which is PbI2. So you add lead nitrate and potassium iodide, you get lead 2 iodide and potassium nitrate. So what we care about is the solid, which is PbI2. That means we care about the lead ion, in this case +2 charge, and we care about the iodine, which is -1 charge. And you should come out to be that reaction.